Hi class, in today's lesson we are going to be looking at the topic of slopes. In the last lesson we have been looking at linear functions. And if you recall, a linear function is just a function that represents a line. So we're going to be looking at one of the characteristics of a line today. And like I said, we're going to be looking at the definition of the term slope. So a slope is just referring to the steepness or the rate of change of a line. Here I have three different examples of lines I have drawn out right here, and they all have different steepnesses to them. This line right here represents a fast rate of change or a fast slope, because we see here that it is a very sharp increase in the line. This is an example of a slow rate of change, or a slow or a slower slope. And then a flat line would be a slope that is constant, meaning that there is no rate of change involved. So slopes can be measured in four ways. They can either be measured as increasing lines, decreasing, constant, or the fourth condition could be undefined. So, we may look at this topic later. Sometimes we may run into lines that are vertical, meaning that they would have an undefined slope, but we'll get to that topic later. So how do we calculate slopes? Well, there is a formula that we can use, and the formula for calculating slope involves knowing the position of your x-coordinates and your y-coordinates on your graph for your line. And so the formula for slope, we're going to use the variable m to represent our slope. And slope is measured as the ratio of two measurements that we're going to divide with each other. The top measurement is going to be the change in our y-coordinates, that's also known as our rise. And then we divide that by the change in our x-coordinates, which is also known as our run. So another term you may use periodically for calculating slope is the ratio rise to run, or rise over run. Just know that they're referring to the change in y divided by the change in x. Now you're probably wondering, what in the world does this symbol mean right here? This is actually the Greek letter delta, and delta is a common variable that's used to represent change. So you may hear the terms delta y over delta x, referring to these two variables right here. So what does that look like on a coordinate plane? Well, consider this example of a line I have right here on a basic xy coordinate plane, and then here are two different points on that line. So the distance from this point to this point right here, we can look at it as the ratio of the change in y to the change in x. And so that gives us our measure of our rate of change, or our slope, for this line. Let's take a look at an example of a problem now. So in this example, what we're going to be doing is we are going to find the slope of a line that passes through the points 2, 3, and 5, 9. Let me fix my paper. There you go. So we're going to find the slope between these 2 points. So remember, we're going to be looking at the change in y to the change in our x coordinates. So if you remember that in our ordered pairs, the first number is always our x coordinate, and the second number is always our y coordinate. So the first two numbers refer to our change in x, or our delta x, and then our second numbers refer to our change in our y, or our delta y values. So how do we calculate a change in y coordinate and a change in x coordinates? Well, remember, anytime that we measure change in math, we're referring to the operation of subtraction. So to calculate the change in our y-coordinates, we just simply subtract the coordinates, the y-coordinates, from each other. And make sure you do it in the same order. It doesn't matter which order you do it in, just make sure it's in the same order for both delta y and delta x. So we'll do 3 minus 9. And then our change in x make sure it's in the same order, 2 minus 5. So now, let's subtract this out. Well, 3 minus 9, well, 3 minus 9 is negative 6. And then 2 minus 5 is negative 3. Now, the negatives end up canceling each other out in this situation. So we end up with the ratio positive 6 over 3, which reduces down to 2 over 1. Now, we can either leave our slope in this as a unit ratio, or we can write it as the whole number 2. Just know that if you see a whole number as a slope, it's always referring to a 2 to 1 relationship, or whatever this whole number would be. So that's how we calculate slope. So let's see how that translates over to, like, if we were to graph these points out, so you have a visual understanding of it. So let's plot these 2 points out so you have a better understanding of how we found that measurement. So the first order pair is at 2, 3. So right there. So there's 2, 3. I'll label that point. And then our next point was at 5, 9. So we go right 5 and then up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we went over 5. So it's about here. There we go. So there's 5, 9. And here's our line right here. Now so if we wanted to see if this is consistent to what we measured out here, then we can just look at the change in our y versus our change in x values. And all we have to do here, we can actually calculate our delta y just by counting the number of units out in the y direction. So that would be starting here. So 1, 2, 3, 4, 5, 6. Oh, that sounds familiar. So 6. And then over 1, 2, 3 units. Oh, look at that. So we end up so it's consistent with our math over here. We got the same ratio, 6 over 3, which is equal to 2. So there's a visual understanding to give you a better feel for how to calculate the slope of a line. Here's some practice problems for us to try out. For these 4 problems, we're going to calculate the slope for the lines that pass through the following pairs of points. Now, if you would like to, you could pause the video right here and you could try these problems out on your own. And then when you're done, you can hit play and compare your answers to see how they match up with my work down below. So let's do problem number 1 first. So we're going to calculate the slope between these 2 points. So when we show our work, we always start off with our formula. So m equals delta y over delta x. So remember, we're going to look for our change in y. So that's going to be 1 minus 4. And then on the bottom would be 5 minus 2. So now 1 minus 4 is just negative 3. And then 5 minus 2 is 3. So we can simplify this down. Negative 3 divided by 3 would give us a slope of negative 1. So that would be our slope for problem 1. Let's try number 2 now. So m equals delta y over delta x. So we're going to do 3 minus 5 for our y coordinates, and then negative 2 minus negative 2. So 3 minus 5 gives us negative 2. But negative 2 minus negative 2, well, that's keep change flip. That's negative 2 plus 2, which is 0. But now, if you know anything about dividing by 0, this is an illegal operation. We're not allowed to do this right here. So we have a little bit of a situation here because we cannot divide our ratio by 0. We end up with an answer that is undefined. So this slope is an undefined slope. So what does that tell us about our line? Well, our line would actually be a vertical line. And that actually makes sense because look, there is no change in our x-coordinate at all. There's only a change in our y-coordinate. So do keep that in mind. All slopes that have a delta x of 0 are always undefined. Let's look at the next problem, number 3. So m equals delta y over delta x. So subtract our y coordinates, 8 minus 7 on the top, and then 0 minus 3 on the bottom. So we get 8 minus 7 is 1, and then 0 minus 3 is negative 3. Well, we get 1 over negative 3, so a positive over a negative number. Now, we're not going to divide this, these two numbers out. We're just going to leave it in ratio form. So do keep that in mind when you're working with slopes. Remember, they're ratios, so you don't have to convert them to decimal values at all. You can just leave them in ratio form if you can't simplify it any further from there. And you probably notice I moved my negative off to the side over here too, because remember, a positive divided by a negative gives us a negative ratio. So now our last problem, m equals delta y over delta x. So we're going to subtract our y coordinates from left to right. So negative 9 minus negative 9 on the top, and then 8 minus 11 on the bottom. So negative 9 minus negative 9, well, keep, change, flip, that would give us a result of 0 on the top, and then 8 minus 11 gives us negative 3. Well, 0 divided by any number will always be 0. So we end up getting a slope of 0 for this one. Anytime you have that, that's always going to be a constant slope. So that is referring to just a flat line, a horizontal line. So let's recap. Just 3 key things in this lesson that we've looked at today. Increasing lines have positive slopes. So that means that when you calculate your slope, you end up with a positive ratio for your answer. Another conclusion is that decreasing lines have, you guessed it, negative slopes. A third conclusion we can make is that constant lines have a slope of 0, and vertical lines have an undefined slope. So those are 4 key principles that you need to keep in mind anytime that you're dealing with calculating slopes of lines. I hope that you found this information helpful. Please let me know if you have any questions for me. Thank you.